basically define, you can define function in two ways. Either as a zip package, basically a folder with code and libraries, or as a Docker image. And one of the very important parts is that Lambda can be invoked by various triggers. What it means is that it's very integratable with other parts of your infrastructure. It could be various things from different queues or API requests. And that's important because you don't need Lambda by itself. You only need Lambda as part of your whole infrastructure part. Now let's take a closer look at how AWS Lambda works. So basically the way it works is that you have to define code and libraries, and basically or Docker image as Lambda configuration plus some parameters. And then once you define it, if service has any incoming events from the trigger, for example, new S3 file, API request, new message from queue, what it will do, it will take function instance from function instance pool, put Lambda configuration within it, process the request, and produce the response. This will be a call invocation because it will have to put initiate basically function instance. But after it's initiated, it will keep it for some time, which may be up to 10 minutes, or it could be more. And in case new event will come in, it will process it faster. So there won't be initialization phase in this case. So now let's take a closer look at how the developing with AWS Lambda looks like, and more particularly, what are the usual Lambda triggers. So usually it's just a way to invoke a Lambda function where you have input and potential output. There are a lot of ways how to do it. The most popular ways are either front-end gateway, so that you can make API requests to AWS Lambda, file storage, or any data storage in general. It could be either S3 or DynamoDB, and S3 is AWS file storage, DynamoDB is AWS DB database, or queue, which could be simple queue service, or SQS for short, or Kinesis. So now, actually, let's try our first demo. So basically, what it will require, so we will be using my binder for running Jupyter notebooks, and Jupyter notebook will have all information about basically we'll have commands for deploying Lambda and running some simple workflow on it. So before we jump into the demo, let me just make a quick Jupyter 101, because we will be using Jupyter for deploying infrastructure and making requests. So Jupyter Notebook, to put it simply, is a way to have mix of code and documentation, where you can run each code cell, and that will execute code within it. So I will show you in the UI, but basically you just need to click play button to run the cell and then wait for completion. And cell icon is very direct. So if it's empty, means that cell wasn't run before. If it has asterisk, means that cell is in progress and you will need to wait for completion. And if it has some number within it, it means that cell completed. So all notebooks are designed in a way that all cells are run sequentially. And if you encounter any issues, please let us know either like in the room or in Slack. Okay, so now let me jump and start the demo. So just to make sure, do you have links to my binder? If not, let me share it in Slack.
Yeah, please share.
Okay, I will share all three, but please only run first one first. So it's AWS tutorial channel. So it may take some time for it to start. And just to make sure, did you share AWS credentials or should I put them also in the channel?
Yeah, please put.
Mm-hmm. So I will share credentials, which you need to put in one of the cells. Which I will show to you here.
And these credentials are the same for all demos in Jupyter today.
Okay, let me try to restart it and run it again. Meanwhile, actually, let me cover the code part while we're waiting for it to start. So the demo which we'll be doing will basically create Lambda API gateway. Actually, it started. Okay, perfect. So basically, as I mentioned, you just need to go through the cells. And for each cell, it will return step finished when cell will finish.
Can you increase the size of the font a bit so it's barely readable inside?
Is it better now?
Yes, thank you.
Okay, perfect. So first we install necessary libraries. Okay, next you need to copy and paste here the credentials which we shared and run the cell. Next, you need to set up unique identifier. Basically, put here your first name and last name. And next, we can actually deploy the Lambda. Let's take a look at the code first. But so basically, let's start the deployment. And while we're waiting for deployment, let's take a look at the code. So here, we're using Python for Lambda. And you can see, what this code does, it takes the body of the request, appends it to hello, and just returns it. And you can see that code is very straightforward and very simple. You just have a handler with event and body, which is part of the event. We take body from it and we return it right away. So you have basically a web server in just 2 lines of code. So this simplicity is what makes Lambda so appealing, and because you don't need to handle any scaling process. Also, we're using serverless framework for deploying our Lambda. It's a framework, open source framework, which is not connected to any cloud, so it works with different clouds actually, and it is focused on deploying function as a service services. And basically, what it does, it creates all corresponding infrastructure pieces. For example, IAM roles and other parts. So now we're waiting for the deployment. Okay, now the deployment finished. Let's take a look at the result. Here you can see that it created endpoint for us. And now let's try to call this endpoint, basically send post request to this endpoint with the word world and see the results. So you can see it returned hello world, basically just appended world to hello, and that's it. But now we can actually also check the logs and verify that Lambda run and that it received the request. So you can see in logs, we will have like start log, meaning that Lambda started. We will have, as you remember in our code, we printed event body, request body. So we see basically the word which we provided, basically here. And finally see the end, duration. And because it's a cold start, we can actually see how much time did it take to start the Lambda and how much time it took to run the Lambda itself. If, let's say, we would run the same Lambda again, we wouldn't have this init time. So let me check the comments. Yes, so my binder may take some time to start. But I think looks like a good post to keep for questions. So let me know if you have any questions on this first tutorial. Sorry, I don't think I heard the question.
No questions right now. I think we're okay. Just maybe give people a minute to catch up with you in the binder.
Okay. Well, to provide more context, you can see I mentioned serverless framework before, but just so that you can see the deployment process was very straightforward. I just needed to run serverless deploy, and it deployed the whole stack. And serverless also provides a way to get logs for a particular function and remove infrastructure if necessary. So basically it does the whole thing for you. And because looks like we have time, and while we're waiting for everyone, let's also take a look at the let me check if I have it nearby. I can show you how the serverless, like to use serverless framework, you need to define a configuration file. And here's an example how the configuration file looks like for this Lambda. So you can see it's very straightforward, just like what type of Python do we use, region, memory size, timeout, handler, index.handler, which is basically name of Python file and function within Python file. And basically that we want to make an endpoint with hello path, and it should be a post endpoint. And that's it. So as you can see, it's very minimal configuration file.
I just have one question about the configuration file. Is there any standard syntax for that? I mean, which all options can be there, which is not possible, stuff like that?
It's an open source framework. So basically it's not an industry standard in the way that like it's more like a live project, which has a lot of changes and it evolves with new AWS features. So
Okay.
So it's not very standardized.
Yeah, in fact, that only raised the question, like because some time back I was trying, and some of the options it was not taking, but some of the options it might take after some time. So I was just wondering if there was a good syntactical pointer to know, okay, these are the correct options to give versus these are not allowed anymore.
Yes, so it has a lot of options. So for that, you would need to check its documentation. But I would definitely recommend serverless framework if you just exploring serverless world, because it helps a lot with deploying a lot of infrastructure.
Okay, thanks.
Excuse me, do you hear me?
Yes.
I was a little bit late, so I did not have any access to the Slack channel. Would you please send me the link for that?
Yeah, we'll do.
Oh,
On
thank you
Zoom.
very much. Thank you.
Rustem, so there is one issue. Security token included in the request is invalid at the step 6 before, like at deploying the Lambda. This is connected to AWS credentials, I believe.
No, it looks like deployment failed. So I think it's best to either restart notebook. So yeah, I think it's best to restart notebook because maybe there was some problem with deployment. Could we have maybe another icon if like people were able to successfully complete the first demo?
Yeah.
Yeah, so on the first, okay.
So in this tutorial, whatever is given after this -d option is the body for the request, right?
Yeah, so this is the body of the request. So currently it's just one word, but it could be a JSON encoded string or anything. Okay. Should we proceed to the next demo? Dmitrii, what do you think?
Yeah, I think we should.
Okay. Let me go back to the slides. So next I want to cover state in serverless. So Dmitrii covered like why state is important and why serverless by definition doesn't handle state like within it, and it has it has to get a state somewhere. And there are two types of state which serverless has to get. It's persistent state and temporary state. And it's best to describe it using an example. Let's say we have Lambda, which does machine learning predictions. And for that, we have model, but we also have input image, on which we want to run the model, and it would make a prediction that there is a cat on the image. In this case, model is a more persistent state because we always load it within Lambda, but it's the same model every time for every event. And we have a temporary one, which is basically cat new image, which we get as part of the incoming request. And this state can reside in different places. It could be part of cloud storage, for example, S3, could be part of database, for example, DynamoDB, or it could reside in intermediate connectors, for example, Q. Let's take a closer look at the different types of connectors. Because basically, and how we can connect Lambdas together and Lambdas with another services. So first option, API requests. For example, REST API or gRPC, which is next is message queues. And finally, orchestrators, which orchestrate, which manage state and call different services. So let's take a closer look at API requests. API requests are pretty straightforward. So we have Lambda function, we have incoming request, Lambda function processes it and produces the response. Main features, it works best with synchronous tasks because we have to process it within some amount of time. For simple intermediate logic, because we are bounded by time we need to produce the response. And it can be parallelized by API gateway, basically by how we make requests to Lambda. And we can use some throttling or auto-scaling logic for handling peak loads. Next are message queues. And here it's also pretty straightforward. So we have Lambda function. We have queue with messages. And each message will be basically start new Lambda. And Lambda will read these messages from the queue. And that is configurable. So Lambda may read one message or batch of messages. But basically, it will just read this message and we'll proceed with it. So on the plus side, it can work with long running asynchronous tasks, although it will be limited by some time because queue service has to receive information about Lambda that it finished processing the message. It may have retry logic upon a function's failure. So if Lambda failed to process some message, it can basically start another Lambda to process it. It can be parallelized by multiple consumers. So for example, in Lambda case, it may there will be we could start 4 Lambdas and it will process this message, this message, this message, and this message. And finally, to propagate state further, Lambda can write state in a different place. Next, let me show the second demo. So basically here we will cover exactly this case where the function will read from the queue and will write messages to S3, and queue will have a dead letter queue configured for it, meaning that if Lambda will fail to process the message, then it will be written to dead letter queue. So we could say it's a very basic serverless pipeline. So now let's open the second notebook.
Rustem, I have a question. Can I ask a question?
Yes, totally.
Yeah. So you mentioned that, okay, if that queue example, if the function fails to read, so is the failure is it because this node can fail to, what could be the reason for failure? Is it the programmatic reason or the it is unable to run the Lambda because of the infrastructure?
That's a great question. It could be both. So, and in both cases, the message will be returned back to queue or to the dead letter queue. It could be a programmatic error. For example, code encountered some internal error on application code level. It could be an infrastructure issue. For example, Lambda doesn't have access to S3 because it was misconfigured. In this case, it will also fail to process the message. I would say the only infrastructure issue which it won't handle if Lambda doesn't have configured mapping to the queue, or there are some issues with mapping, then Lambda won't receive message in the first place.
Okay, thanks. And just related to that, like if say while running the Lambda, I'm trying to understand the failure model. If say pod fails or something, right? So would it actually retry the execution?
Yeah, that's a good question. So it's configurable. So you can configure number of retries before it will be sent to that letter queue. And basically, this type of mapping has a lot of different parameters: retrying, like waiting, like after retry, and so on.
Okay, got it. Thank you.
Okay, let's proceed with second demo. basically here the sequence is the same. We just need to pass credentials and run cells sequentially. Okay. Keep in mind that it may take a bit. Okay. It may take a bit longer to deploy it this time because it will need to create queues. Just want to cover code as well here. So as always, only like 10 lines of code. So basically what we do is we parse event, and in case with SQS, it has, as you can see, event will look differently. It will have records field, and within the records field, it will have a body. Currently, we will emulate the error. So if the message is not equal to value error, we'll just print a message body, message ID, and we will save this file as to S3 with message ID as key and with message body as file value. And in case we send message with value error body, we will raise value error, basically fail the message. And one additional thing which you can see, in this case, it doesn't matter what we return on handler. We just need to complete the handler successfully. But for SQS, it would mean that we successfully processed the message. But if we didn't reach the return, because we're, for example, here we will raise value error, then for AWS, it would mean that we didn't read the message correctly. And it will be retried or sent to the letter queue.
Or make it run in an infinite loop if we pass value error, because it will every time it will try to execute this function and it gets value error and release it, send it back to the queue which will pass.
Sorry, what does it show? What does it say? What's there?
So if we in the code, the value error is a parameter passed by us in the request, correct?
Yes. Basically, in our case, we will send two types of messages. We will send one message which is not value error and see how it works. And then we will send another one as value error. So basically, we're kind of emulating error scenario here.
Right. So for the value error scenario, it will raise the value error, right? And you said that it's gonna send this message back to the queue as it is not finished correctly. And
Yes.
the Lambda instance will again try to pick the same message again from the queue, is it not?
That's correct. Depends on how you define.
Okay.
So you can define it with retry number 1, and it will mean that it will only try it once, and if it fails, it will send it to the letter queue. You can define it that it will retry 10 times. So basically, it's very configurable.
Okay. So do we have that configured here in our instance?
Yes. So let me show you the configuration file. While we are waiting for the deployment. So here you can see the example. So this is also serverless configuration. This is the read queue which we defined. We defined the letter queue and we define max receive count. But so here it's 1. So meaning after fail, it will redirected right away, but this number could be like 10, for example.
Okay, got it. That makes sense.
Okay, we deployed the queue. Now we can see both queues here. So it's read queue URL and the letter queue. Now let's start sending messages to the queues. First, let's send a normal hello world message. We can see the message ID, which was created. And now first we can check that logs were successful for this function. So we can see that it processed the message, it has correct message body, and we can verify that it has correct message ID. Basically the same as here. Next, we can actually check S3 because now we have message ID and we can verify that it actually created the file with hello world. So we can basically download and check the file based on this message ID. Okay, it has some issue, but basically you can see that it showed hello world, which is basically it showed the contents of the file, which it saved to S3. Now let's actually send the value error message to the queue. And now let's see and check the logs this time. So as you can see, it started. So we see previous log, we see current log. So it started and it just raised value error. So it didn't complete and it failed. And now let's check and see that because we failed to process it, this message, it will be sent to that letter queue. Okay, let's wait a bit because sometimes it takes time for it to appear. Now you can see that this message with value error is now in that letter queue. And there are different things we can do with it. So we can either use it for debugging or troubleshooting stuff, or you can connect another process to this letter queue, which would do something with these messages. Okay, quick pause here. Was anyone able to run it? Does anyone have any issues? And also, if you have any questions about this demo, would be happy to answer.
Yeah, just a quick one. So in the step 7, when we added a message into the queue, can we run that, let's say 2 or 3 times and see we have multiple entries in the queue? I tried and it's not showing multiple entries there. Then can you try?
Which step, sorry?
Step number 7, when we are adding the message into the queue. Yeah, just put, let's say, hello 1, hello 2, hello 3.
Yeah, so what it will do, it will make a new message, and we can check the logs that it now should show the new message here. Hello 3 with new message ID. And I think we can check that it created it on S3 side. Basically what it does, it finds this message ID from the logs. So yeah, it currently takes the first one, the first message ID, so it shows hello world. But basically, if we would check this message ID on S3 side, we would see the new message body. Okay. Looks like demo completed for 5 people. Just wanted to check, does it take more time? Did any issue happen? Okay, while we're waiting, let me actually show also how SQS looks like in the wild. So AWS also provides a web console, and that could be useful to basically see the queues which we created in the web and see the results and everything. So you can even send custom messages to the queue and see the whole parameters, see statistics and everything. So that's a neat way to kind of monitor the performance. And you can even see the messages themselves. So you can poll for messages and find the message which was failed. So basically the same thing we got, but just using Web Console. Okay. If there are any issues, please post comments to Slack, but I think it should be safe for us to continue. Okay, now let's go next. And finally, there is a third type of connectors called orchestrators. And orchestrators basically handle inputs, outputs, and they keep state within themselves and call different services. For example, in this case, it would first call Lambda A, get the response, and then would use it to call Lambda B. And it's best for working with asynchronous tasks. For example, it can handle tasks which run a very long time. It has information about workflow state within it. And because of it, like it can be very flexible when handling retries or errors, or it can also parallelize tasks. Compared to SQS, for example, orchestrator can have a more customized logic for errors. And for different errors, it may have a different handling mechanism. For example, with SQS, all errors would go to dead letter queue. So to take more closer look at AWS Step Functions, and AWS Step Functions is basically orchestrator implemented by AWS. It has graph-based workflows, and it acts basically as a glue between different AWS services and has support for a lot of them. Has custom error handling, as I mentioned before. And one interesting thing it has is parallel dynamic execution, meaning that here, let's say we have a workflow, and step start can generate arbitrary amount of tasks, let's say 20, and step task will process all these 20 tasks in parallel, and step reduce will wait for all of them to complete and will gather the result. Along with that, it will have logic for branchings and loops as well. So now let's take a look at the first demo, basically where we will have AWS Lambda workflow with orchestrator, with step function, which will where one Lambda will generate task, another some number of tasks, then these tasks will be run in parallel, and then reduce will gather and assemble the results from the task step. So let's go to for the third link. Okay, so as always, the process is the same. Please run the steps sequentially.
And do not forget to update the environmental variables.
Yes, that's a very important step. Okay, yeah, step finished. Okay, let's take a look at the code and yeah, let's start the deployment process. So as you remember from the like from the diagram, we will have 3 lambdas here. But we will use a very neat life hack where we actually will all these 3 lambdas will have the same zip package, but they will have different handlers. So configuration-wise, they will reuse the same package, but because they have different handlers, they will basically have different code, even though like their code is present in the same file. And here we can see like how it will work. So one map lambda will just generate tasks. In this case, 3 tasks with just task ID. The task lambda will create a result field, which is basically task ID plus 1. And reduce lambda will basically sum all results across all the tasks and print the result. And while we're waiting, let me also highlight how the configuration file for the step functions will look like. So here you can see all 3 lambdas which we have. So you can see that they just have different handlers. Next, we have a state machine, which is basically a graph-based notation language, where for each step, we define basically what type of task it is, what type of lambda it will use, and what is the next step. And that's it. So we define first step, we define next step, which will basically parallelize tasks. And finally, we have final task, which will get all the results. And we mark it as end true to mark that it will be the end of step function. Let me check the deployment process. Okay, still going through. So interesting part about step functions is basically, as you can see here, it's a bit more complex because now you need to define the whole execution graph, and that makes it harder to debug. But at the same time, although in my example, I was using Lambda, you can, a lot of other AWS services could be like placed here instead of Lambda. Okay, now it's deployed. Let's see the logs. So it generated the service endpoint for starting step function. Let's actually invoke this step function. Okay, we can see that it started it, and we can even see the execution ID. And now let's check the logs of each individual Lambda. So first, it will be map Lambda. And here we expect to see all the tasks which we generated. We can see all 3 tasks as expected. Next, we check Lambda task. And for Lambda task, we expect to see 3 parallel tasks. And you can see it here. So basically, they happened in parallel so much that they have mixed logs. But basically, it's not the same Lambda. It's basically 3 parallel Lambdas processing stuff. And we can verify it because, as you can see, all of them are called starts. So all these 3 lambdas have called starts because they all were started without any initial requests. And finally, we can check the reduced lambda to see the final results getting in one place. Yeah, so you can see here that we got all task IDs, results. We've basically accumulated, counted sum of all results and got the final number. So, okay, let me do a quick pause here. Let me know if you have any issues with deployment or any questions about it. Okay, since we have one additional minute, let me actually show you how the step functions look like in Web Console, because it's also they have very neat visualization. So the advantage here is like one of the challenges in general, we're dealing with connectors is to troubleshoot stuff. And here, along with lambdas, you can see actually how the whole workflow worked. When something started, when it ended, but also for each step, you can see what was the input and what was the output. We saw it in the logs, but basically we saw it, it's very convenient when you can see it in a graphical way, like here. And in case some step would fail, we would also see the failure, like or the error name or type here as well. Okay. So looks like there are no issues with demos. So let me finish the slides so that we have time for break. So let me just like go through the final slides and go through the state of AWS Lambda today. So going through different demos and seeing how it works, we can see that it has a lot of pros. It's very easy to deploy, connect to different types of connectors. It's very scalable and it's very convenient. But there are some cons. It's very hard to have like full local Lambda environment to make sure that basically you can reproduce what happens in the cloud locally. And there are no performance guarantees, both in case how it will start lambdas, but also how it will handle cold starts. For example, I mentioned that like if you have a new lambda, it will be warm for 10 minutes, but that's not guaranteed. And it may change depending on allocation of resources within AWS region. And there are a couple of limits which you have to keep in mind with Lambda. Its execution type up to 15 minutes, its memory RAM, disk, and concurrency. So where it could be used? When you have simple compute because it only has CPU. If you have to handle peak loads, then pretty good because it can scale pretty fast. Some periodic tasks, basically it's great at doing cron jobs. If you need to parallelize some simple task, it would be great as well. Or you need to do some prototype because it's very cheap. Where it's not yet very efficient. So if you have latency critical workloads and you need to basically produce some response in 2-3 milliseconds. If you have to process a lot of data, like 50 gigabytes of data and so on, then Lambda wouldn't be an option because it has a 15 gigabyte limit on memory. If you have some compute-intensive workload or high load serving, then Lambda wouldn't work in this case as well. So main takeaways, which I want you to take from this talk, is that Lambda is leading the serverless cloud, and it's very easy to start working with it. You can see that it's very flexible and you can do a lot of different stuff with it, with dynamic invocations and different orchestration. But with a lot of stuff, you still need to understand, like you need to test it and benchmark it to understand whether it works in your case. So I would definitely promote joining the vHive initiative and using it to benchmark and understand whether Lambda will work in a particular case or not. So thank you very much for your time. We'll be happy to answer any questions if we have time, but feel free to send me any emails or connect with me about my website if you have any questions about it. And I have some open source GitHub repos, so feel free to check them out as well. And thank you very much for your time.
Yeah, thank you very much for your tutorial. Especially he's halfway around the globe, and I think it's 2 in the morning or so where you are.
Yeah.
So yeah, thank you very much for still coming to the tutorial and helping us and guiding us through this Amazon. It was very interesting. Thank you.